Hello everybody and welcome to a new ROS questions and answers video. And in the video of today I'm going to be showing how to set up a MoveIt package for controlling the fetch robot. So for that, the first thing I'm going to do obviously is to launch a fetch simulation. Here I have one. In this project I have here. So I'm going to launch here my fetch simulation. As you can see, I'm in the ROS Development Studio. Here I have the website. So let's launch the environment first of all. Let's wait a few seconds until it loads. There it goes. Excellent. So now, as you can see here, I'm going to open the code editor. Here in the simulation workspace, I have a fetch simulation, with fetch packages. So what I'm going to do is to select one of the launches. In this case, I'm going to be using this one here. Let's launch it, and this will launch a fetch simulation. Okay, there it is. It is loading. So meanwhile it ends loading, I'm going to start a shell because I'm going to be using a shell. So let's start a shell right here, and also let's open Graphical Tools tab in order to visualize correctly the MoveIt setup assistant and MoveIt. Okay, so let's see how it goes. Okay, let's have a look at the simulation. Okay, so there we have it. It is load. Excellent. Here we have our fetch robot. Great, so let's minimize this for the moment and let's launch in the web shell. I'm going to minimize as well the code editor. So let's launch first of all the MoveIt setup assistant, which is the tool we are going to be using in order to create our MoveIt package. So let's launch the MoveIt setup assistant. There we are, and here let's log in to our graphical tools window, and here we have the MoveIt setup environment. So let's first of all select create a new MoveIt configuration package. There we are. Then we will have to choose the URDF file we want. In this case, the URDF file is here in the fetch description package. Inside the robots directory, it's this one here, the fetch.urdf. So let's open this file and load it. There it is loading. Now when it finishes, the fetch robot will appear here. There we have it. Okay, so we have it loaded. So then the first thing we will need to do is to set up the self collisions. And this is very easy. Just click here in the regenerate default collision matrix. And this is in order to disable some pairs of joints from doing collision checking. Like for instance, adjacent links, because they will be always be in collision. So there is no need to check if there's collision or not, because obviously if they are adjacent links, they will always be in collision. Yeah. So this basically does that. It disables some pairs of joints, some pairs of links for doing collision checking. Then in this case, the virtual joints, we are going to leave it blank, and then we are going to add first of all a planning group for the arm. Let's do this bigger so you can view it better. Okay, so then the first thing we are going to do is to add a group for the arm. So let's create a planning group which we are going to call arm. Then we can select, for instance, the KDL kinematics plugin, this one here. And then let's add some joints. the ones for the arm, which in this case are shoulder pan, shoulder lift, upper arm roll, elbow, forearm, the wrist flex, and the wrist roll. Okay, as you can see here in the MoveIt, here in the simulation window, these joints appear in red here in the robot, and these are the ones that correspond to the arm of the fetch robot. Yeah, so this is the ones we are going to add. These are the joints that are going to be part of this planning group. So let's add them and save. Excellent. Then we can also, if you want, we can also add another planning group for the gripper. In this case, we are not going to be using the gripper, but let's just create it. We can leave the kinematic solver in blank in this case. And let's select the gripper joints, which are these ones here, the gripper finger left and the gripper finger right. Let's add them here and save again. And there we are. We have our two planning groups here, one for the arm and another one for the gripper. Then let's create a robot pose for doing some plans. So for instance, let's call this start. And then, okay, let's put this to -1.0. This one to 1.5. Okay, we can leave it like this. As you can see, it is a very simple pose. So let's save this pose. There we have it. And then for the end effector, let's also add an end effector, which we can call gripper. The end effector group will be, of course, gripper, the one we have created before. The parent link will be the wrist roll link, this one here. And finally, the parent group will be arm. Okay, so there it is. Let's save it. And that's all. Let's fill up this author information with wherever. I'm going to put test here. And finally, let's create a package. I'm going to create it inside the Catkin workspace directory. So let's inside here create a new folder, which I'm going to call my fetch MoveIt config. There we are. Let's choose this directory and generate package. Okay, yeah, it says that no virtual joins have been added and no valid email address. Okay, this is important because if not, it won't leave me create the package. So let's add here .com so that it detects this email address as correct. So let's generate again the package. There we are. And okay. So here it is generating the package, as you can see. And there we have it. Configuration package generated successfully. So let's exit the setup assistant. Great. And then now, if I come here to the Catkin workspace, I will see my new package. Here I have it, my fetch MoveIt config. Excellent. So now we can test if this is working correctly. Let's launch it. ROS launch, my fetch MoveIt config demo.launch. Okay, this demo.launch will allow us to, it's generated by default, of course, and it will allow us to check if everything is working fine. So let's go again to our graphical tools window, and here RVS is being launched. Okay, now as you can see, this appears out of focus. In order to solve this, we are going to execute a command here in the shell. The command is basically, I'm going to paste it here. It's this one here. This will allow us to move this window here in the remote desktop. You can see it there. and now we can maximize it and we can visualize it correctly. So okay, yeah, here we have our fetch robot. So let's go to the planning tab. Now here we can select our start pose, which is the one we have created right a few moments ago in our in the setup assistant. So let's update the goal position. Here we have it, and then we can click on the plan button. Here it is planning, and there it is. It has calculated a plan in order to go there, and as you can see here, it is showing me how this motion would be. Yeah, but this, what you are seeing here, it is just a simulation inside the MoveIt RV's environment. So this is not happening in the simulation, in the real robot. As you can see here, this is not affecting this robot. So let's do a couple of modifications into our MoveIt package so that anything we do here, so now if I click here on the execute button, it says here that the motion has been executed, but it is executed only in this simulation. Yeah, in the robot, in the real robot, which is this one here, the motion is not being executed. Okay, so now what we are going to do is to basically connect the MoveIt environment, this environment, we are going to connect this to the actual real robot, in this case this simulated fetch robot. Okay, so that anything we plan and we execute here in MoveIt, it will be done in the real robot. Okay, so yeah, let's go. Let's do a couple of modifications to our package. So for that I'm going to open a moment the Robotic Knight Academy in order to check a couple of things that I don't remember very well now. So yeah, I'm going to open the manipulation course of the Robotic Knight Academy, and I'm going to have a look at a couple of things. So let's here click on the start course. There we are, and I'm right in the correct unit. I'm here in the creating a MoveIt package chapter. So excellent, let's wait a few seconds until the environment loads. Okay, so here we have our Robotic Knight Academy almost loaded. It is still loading the simulator, but well, I'm going to just have a look to the notebook, so I don't care about the simulation yet. So let's maximize this notebook here. And okay, so here we have the first section, which is generate a MoveIt configuration package using the setup assistant tool. I have already done this step, so I'm going to skip this part of the notebook. Let's go down. Okay. Some basic motion planning. I also have done this. I have executed this demo.launch file, so I have also tried this and it works fine. So I'm going to go to the last step, which is to move the real robot. So here, okay, this is what I wanted. Okay, so basically here, what I'm going to be doing is to, first of all, we need to create a controller's YALM file inside the config folder. Okay, so that's the first thing I'm going to do. So let me minimize this, also this and this, okay, and also this. Okay, so here I have my package. So inside the config folder, I'm going to create a new file, which I'm going to call controllers.yalm. Okay, then inside this file, let me paste this here. Okay, so here I will define the controllers for the different groups of joints. Yeah, so in this case here it is defining the ARM controller, but this is But this is specific for this chapter and for the robot that you are using in this chapter, which is a UR5, as you can see here. So I will need to adapt this to my robot, to my fetch robot. So yeah, here I will define the controller for the arm. So let's have a look at my simulation. So let's do here a ROS topic list to see the names of the topics that control the arm of the fetch robot, which should be up here. Okay, so here I have my controller for the arm, and as you can see, yeah, the name is arm controller, so this is fine, and the namespace of the action is follow joint trajectory. Okay, so this is also correct. The type is also follow joint trajectory, so this is right. And the name of the joints, this is different, so here I will need to add the names of the joints of the fetch robot. So let me open just a moment again the package I have just created to have a look at the names of the joints. Okay, let me have a look here. Edit existing movie package. I'm going to open the one I have just created. Here I have it. Choose and load files. And great, here in the planning group I'm going to have a look at the joints. Okay, so they are shoulder pan joint, shoulder lift joint, so shoulder pan, shoulder lift, then upper arm roll joint. Okay, let's modify it here. Upper arm roll joint, there we are. Okay, so upper arm roll joint, elbow flex joint is the next one. Let's add it here. Elbow flex joint, there we are. Then forearm roll joint. Okay, let's put it here. Forearm roll joint, and then we have wrist flex and wrist roll. Okay, wrist flex joint, and let's add another one, wrist roll joint. Excellent. Then here we have the controller for the hand. In our case it was the gripper. So let me see if I see here the gripper controller. Okay, here I have it. Gripper controller, gripper action. Okay, so in this case the name is gripper controller and the namespace is gripper action. Okay, so let's put it here, gripper action. And here I have just two joints, which are L gripper finger joint. So let's put it here. Okay, L gripper finger joint and R gripper finger joint. So left and right. There we are. And finally, regarding the type, this one is correct. The first one is correct. So if I do, if I have a look here at the, for instance, ROS topic info, the ARM controller follows, okay, of the goal, I can see here that the type used is this follow joint trajectory action. Okay, in this case it's the goal topic, so it's the goal message, okay? But basically the type is this one here, the follow joint trajectory, yes? Sorry, here we have it, the follow joint trajectory, okay? But if we do the same for the gripper, so let's do our ROS topic info of the gripper controller, gripper action, goal, for instance. Here I have another type of message. Okay, it's not the follow agent trajectory, but it's this gripper command. Okay, so let's modify the type here and put it to the gripper command. Okay, and that's it. Excellent. So we have our controllers.yelm file. Then the next step will be to generate this joint names.yelm file. Of course, if you want to check more information, you can come here and read it, but I'm going to do this quickly because I'm just coming for some basic knowledge. So yeah, let's create this joint names.yelm file here in the config folder. So new file, joint names.yelm. Excellent. So here what I will basically add are all the names of the joints. So I will have to come here and copy paste all of them. There we are. Let's try to do it fast. 2, 3, 4, 5, 6, 7, we are almost done. Okay, 8 and 9. Here we have it. Excellent. Okay, so we have our join names configuration file created, our controllers configuration file also created. Then we will need to fill this launch file here, the whatever MoveIt controller manager launch XML. So let's find this launch file in our package here inside the launch directory. It is this fetch MoveIt controller manager launch XML. Okay, MoveIt controller manager launch XML. So let's copy the contents here. Let's open our fetch MoveIt controller manager and copy paste this here. Okay, so now we are going to change here the name of the package. In our case, it's my fetch MoveIt config. So let's modify this, my robot for my fetch. It is just here. So here, as you can see, we are going to be loading our controllers YAML file. So let's save this launch file, and finally let's create a new one, which will be the planning execution launch file. So let's create a new launch file here, where we are going to call my fetch planning execution.launch. So again, I'm going to copy the structure and then do the modifications for my fetch robot. So okay, let's change the name here and load our join names file. So we are going to put here our package, my fetch MoveIt config. Also here, my fetch MoveIt config, here, and here finally. Okay, so we are loading different launches. Basically, the main here is to load the join names configuration file and this move group launch, which basically is the launch that starts all the MoveIt environment. And then here, what we are doing is to set up the joint states topic of our robot. In our case, let's have a look. This topic, the states topic, is the topic that tells the state of all the joints of the robot. And as you can see here, it is joint states as well. So this is the topic that will tell me information about the states of the joints of the fetch robot. And so here I don't need to change anything. It is correct. It is joint states. So let's save this and we are done. So let's test our package. Let's minimize all this. Let's close setup assistant and let's launch our new MoveIt setup. So ROS launch, my fetch, MoveIt config, my fetch, planning execution. Here we have it. So now MoveIt will start right here. Great. So let's put here the command. Great. Here we have it. Okay, let me close this. We don't need it anymore, so let's close it. Okay, there we are. And now let's try it. So we have again our MoveIt environment. Let's again do a plan to go to our start position. So let's do a plan here. There we are. So, okay, here we have the plan, and now let's see if we can apply this motion to the simulation. So let's put this here and let's put the simulation right here to view it better. Okay, so let's put it here for instance, and now after the plan is done, let's execute this trajectory and see what happens. So let's click here on the execute button, and there we are. We have MoveIt robot executing this trajectory. There it is. It is doing the trajectory, and it will end up in that position. There we are. Excellent. So yeah, here you have. I have created a MoveIt package for controlling a fetch robot. Maybe I know I have gone a little bit fast in some parts of the video, but well, feel free to review it, pause it. You can also go to the manipulation course in the Robot Ignite Academy, the one I have showed, and review the different steps, what are you doing in each step. So yeah, in this video I just wanted to show how to do it in a quick and fast way and show you that it works. So yeah, you can now do it if you want in a slower pace. And well, if you have liked the video, please leave a like, subscribe to our channel. We post videos like this every day, and also remember to click on the bell in order to get all the notifications when we publish new videos, when we do live streams or whatever. Okay, so well, goodbye and see you in the next video.